In this video, I'm going to do a couple of things. First, I'm going to prove the external angle theorem when we deal with triangles. It's a pretty important idea to have. And then the next thing I'm going to do is I'm going to go through some example problems dealing with the external angle theorem. It's going to be typical of what you might see on like your math homework. Okay, the external angle theorem says this. By the way, external means outside. The angle outside, which in my picture is A. See, we have a conjecture. Sometimes it's called a conjecture, a conclusion we can draw about it. Same thing as a theorem. But there's things that we know about A. For instance, let's start off with some easy stuff. Don't I know that B and C and D have to add up to 180? Probably so, right? B and C and D both add up to 180. We call that the triangle sum conjecture, or the triangle sum theorem. Okay, I have another video about that if you need to know, but that's a fancy way of saying the angles on the inside add up to 180 degrees. I also know that if I forget about D and C for a second, if I just look at A and B, that A and B have to add up to 180 degrees. Why do I know that? Because they're either, I call them supplementary angles. I can say that they're a linear pair. I don't really care what the justification is here. Let's say that they're supplementary angles. Okay? That's a term that most of us are familiar with. Now comes the fun. You see, if these three angles add up to 180 degrees, and these two add up to 180 degrees, then can't I conclude that maybe these two, the left parts, aren't they equal to each other as well? I mean, they both add up to 180, right? So let's set them equal to each other. Let's say that the A plus B is the same thing as the B plus C plus D, right? They're both 180 degrees. Now this idea that if they're both equal to 180, that I can set them equal to each other, if I want to use the fancy terminology, if I want to sound like a mathematician, I'm going to call that the transitive property of equality. Transitive property. Okay? Fancy way of saying, hey, listen, I can set them equal to each other. Okay? Now, last step. See, I have a B on both sides. Couldn't I subtract that out? I mean, what's the point in adding B to both sides here? So if I cross that off and I cross this B off, I'm left with A is equal to C plus D. And I knew that because I could subtract B from both sides, right? That's called the subtractive property of equality. Subtraction property of equality. That's if I want to sound fancy. Okay, I want to sound like I know what I'm doing. Okay, but that's a fancy way of just saying, listen, I know I can subtract B out from both sides. I can subtract the same value from both sides, and things are fair. I haven't changed anything in the equation. But the conjecture that I can draw then is if I have a diagram like this, that A, this angle here, is equal to the addition of the angles across from it over here. A is going to be equal to C plus D. That's a pretty important idea. That's the external angle theorem. So it takes complicated problems and it makes them easier. For example, 3 examples. Ready? Take this. What's X? What's 7X? Right? That looks awful, doesn't it? But here's what I know. I have an external angle, right? It's outside. Maybe it would help if I went like this and made it look a little bit more like the picture, right? Let's call this 7X. The two angles that are not next to it, so in other words, not this one here, but the two angles across from it are 90 and X. And the external angle theorem says if I take 90 degrees and X degrees and add them up, they add up to 7X. So let me do that. Flip the paper back over for you. If I add together the 90 degrees and the X, the two angles that are not next to the 7X, that's what they'd add up to. That's the external angle theorem. Now I just need to solve for X, right? So let's take the X and subtract it from both sides. 90 is equal to 6X. Let's divide the 6 out. So if I divide both sides by 6, that goes away. X was 90 divided by 6, which is 15. Or if I needed to know what this is, I could take 7 times 15, and I know that this angle here is 105 degrees. Pretty simple, right? Whoops, went off the page there. Okay, here's another example. Man, that camera brightness is weird, isn't it? I apologize for that if you're watching this. I don't know what's causing that. Here's another example. Let's say that points A, B, and C are collinear. That means that this is a straight line, in other words. A, B, and C are collinear means it's a straight line. The measure of angle DCB is 100 degrees. So if I go from D into C and then out to B, this angle formed here is 100 degrees. The measure, that's what M stands for, measure of angle CDB is 20 degrees. So if I go from C into D and then out to B, the angle formed by that is 20 degrees. And I want to know what the measure of angle DBA is. D into B, out to A. That is this angle right here. That's what I'm going for. And instead of a question mark, maybe I can say that, hey, I'll call that X or something. It doesn't matter. Now, I can do this the long way, which says this. I know that if this is 100 and this is 20, it's 120 of 180 degrees is taken up with this triangle. That means the remaining 60 are right there in this inside, right? And then I could go from there and say that, okay, if I know that this is 60 degrees and these two form a straight line, that they have to add up to 180, which means this here is 120 degrees. I can get 120 degrees the long way, and I understand that in some problems that's pretty possible. But here's the nice thing. The external angle theorem says if I'm looking for this angle, that I just have to add up the two that aren't connected, the 100 and the 20. I had a shortcut to get there, right? It makes it a little bit more complicated, makes it just a little bit easier. Whatever floats your boat, okay? Whatever you can remember. Last problem. Let's solve for angles A and B. See, once again, this looks pretty complicated because you're going to write out things like A plus B plus 36 is 180 degrees. Or you're going to come through here and you're going to say 60 and 46 and this angle here add up to 180, right? So if I just look at that, yeah, there's a way that I can do this problem, but you know what's nice is if I look at angle A and I know the external angle theorem, I know that it's the external of this triangle here. Here's the angle that's connected to it. You know what? If I take the other two, 60 and 46, and add them up, that gives me A. This is going to be 106 degrees. And if I know this is 106 and this is 36, that's 142 total, right? If I know that's 142 between these two, well then if I take those away from 180 degrees, that means this thing here has to be the remaining 38 degrees, right? So A is equal to 106 and B is equal to 38 degrees. And I did that problem pretty quickly, only because I know that this angle A is the addition of 60 and 46. That's three pretty typical homework examples that might involve the external triangle theorem. You'll notice that in most of the problems I had other ways I could have done it, right? A longer method. It's just a shortcut. It's a nice way that makes complicated problems a little bit easier to solve.